A $500 plastic drone soaring through the sky can now render a multi-million-dollar armored vehicle completely useless. This harsh reality has defined the battlefield for the past 2 years, leading global defense analysts to argue that the era of heavy armor is officially over. However, in mid-2026, the Russian defense industry delivered a massive blow to this narrative with the official deployment of the newly upgraded T-80BVM tank. This specific Russian armored vehicle is no longer a defenseless target. By July 2026, factory delivery data from Omstrensmash confirmed that these heavily modified units are entering frontline service with integrated protection systems designed to neutralize the top attack threat entirely. For tank crews, failing to adapt meant being exposed and utterly vulnerable to precision loitering munitions. But on paper, their only tactical salvation would be a radical engineering evolution. Russia did not rely on a futuristic concept like the T-14 Armata. Instead, they took the existing T-80BVM and encased it in a factory-built protective cocoon. This configuration features multi-layered mesh armor grids alongside an advanced electronic warfare suite capable of jamming frequency-hopping signals from 400 MHz to 5.8 GHz. This setup cuts the video feed of incoming first-person view drones before they can strike. Combined with the high-speed agility of its 1,250 horsepower gas turbine engine, the T-80BVM can now execute rapid shoot and scoot maneuvers, retreating at over 20 kilometers per hour before an operator can even lock onto its position. How did a Cold War legacy platform transform into the ultimate drone hunter of 2026? Before we go on, do you think heavy tanks can truly survive the drone revolution? Subscribe now to stay ahead of the latest global defense breakthroughs, and tell me where you are watching from. The secret behind the survival of the 2026 variant of the T-80BVM lies in a major shift from improvised battlefield field modifications to standardized military engineering. Leading global defense analysts argue that the chaotic era of crude welding on the front line has officially been replaced by a highly sophisticated, multi-layered defense matrix built directly into the assembly line. The first layer of defense is the new factory-built protective cocoon armor. Unlike the restrictive steel cages seen in 2024, which heavily blocked the situational awareness of the commander and slowed down emergency evacuation, the 2026 configuration utilizes modular, lightweight grid structures. These geometric steel meshes are precisely spaced to deform the shaped charge warhead of incoming RPG-7 projectiles, commonly attached to low-cost loitering munitions, causing them to detonate early at an unharmful distance from the primary armor plating. However, passive protection is useless if a drone manages to find an exposed gap. To neutralize this, Russia has equipped the T-80BVM with an advanced active electronic warfare jamming system mounted directly on top of the turret. Official technical data available in mid-2026 shows that this electronic suite constantly scans and emits interference across an expanded radio spectrum from 400 MHz to 5.8 GHz. By utilizing rapid frequency hopping algorithms updated in March 2026, the jammer cuts off the crucial video signal between the first-person view drone and its remote operator, leaving the incoming weapon completely blind moments before impact. For any drone that managed to bypass the electronic shield, the final salvation on paper is the ArenaM hard kill active protection system. Operating with a specialized millimeter-wave Doppler radar, the ArenaM maintains an ultra-wide tracking envelope with an elevation coverage reaching up to positive 65 degrees. When the radar detects a low-speed object traveling between 70 and 200 meters per second, it automatically launches a targeted fragmentation countermeasure, destroying the threat in mid-air within a lethal radius of 1.5 to 50 meters away from the vehicle hull. Beyond advanced passive protection and hard kill systems, the ultimate survival trait of the upgraded T-80BVM is its remarkable tactical mobility. Leading global defense analysts argue that armor thickness alone cannot ensure survival on a transparent battlefield, making raw speed the ultimate asset. The mechanical heart of this 46-ton armored vehicle is the GTD 1250 gas turbine engine, which generates an impressive 1,250 horsepower. This high-performance powerplant creates an exceptional power-to-weight ratio of approximately 27 horsepower per ton, allowing the vehicle to accelerate instantly and achieve a maximum road speed of 70 kilometers per hour. This specific engine capability provides a critical advantage over other Russian variants like the T-80BVM or the T-90M, which utilize traditional diesel engines. While traditional diesel variants are notoriously slowed down by a restrictive reverse speed of only 4 to 5 kilometers per hour, the gas turbine architecture of the T-80BVM enables a rapid reverse speed exceeding 20 kilometers per hour. In the current conflict environment of mid-2026, this rapid reverse capability enables the execution of an evolved shoot and scoot doctrine. Satellite data tracking at the Omsk production facility indicated a noticeable reduction in stored vehicle hulls during the first half of 2026, dropping from 253 down to 203 units, as the factory accelerated deliveries to active combat formations. Frontline reports reveal that instead of forcing these vehicles into dense minefields, commanders deploy the T-80BVM as highly mobile assault guns. Cooperating closely with nearby reconnaissance drones, the tank quickly fires 3 precision rounds from its 2A46M5 125mm smoothbore gun, before instantly utilizing its reverse gear to retreat into dead zones or forest cover. This entire tactical sequence takes less than 45 seconds, meaning the vehicle has departed before an enemy loitering munition can even arrive at the coordinate. While the upgraded T-80BVM demonstrates incredible technological adaptation, in mid-2026, leading global defense analysts argue that no weapon platform is entirely without flaw. The rapid evolution of the gas turbine engine provides unmatched acceleration, yet it simultaneously introduces 2 major tactical vulnerabilities that cannot be ignored. First, the gas turbine architecture creates a massive logistics burden due to its extreme fuel consumption, which is twice as high as a standard diesel engine even when idling. This reality forces frontline supply lines to transport massive quantities of fuel under the constant threat of aerial interdiction. Second, the ArenaM hard kill system detonates fragmentation countermeasures at close range to intercept incoming weapons, effectively creating a hazardous zone for supporting infantry moving within a 50-meter radius of the vehicle hull. This friction limits seamless combined arms operations. Despite these limitations, the strategic lesson offered by this upgraded Russian armored vehicle is profound. In a prolonged war of attrition, victory is not determined by purchasing flawed, ultra-expensive $10 million platforms that are too complex to mass produce. Instead, Success belongs to the nation that can take an existing $2 million chassis, implement practical factory upgrades, and field a resilient asset that is optimized for contemporary threats. The T-80BVM proves that heavy armor is not disappearing from the modern battlefield. It is merely undergoing a rapid evolution to survive the drone age. As Western defense planners continue to develop next-generation concepts like the M1E3 Abrams to counter these aerial threats, the question remains whether high technology or rapid industrial adaptation will ultimately win this race. Will the reliance on expensive premium armor eventually fail against mass-produced, cost-effective modifications? Or is the era of the heavy tank truly nearing its end? Turn on notifications and share your thoughts below.